Hello everyone and welcome to the lecture on Amazon Managed Workflows for Apache Airflow. So this lecture will contain all these topics. What is Amazon Managed Workflows for Apache Airflow? Features, complete architecture, integration and a sample tag. So what is Amazon Managed Workflows for Apache Airflow? So Amazon Managed Workflow for Apache Airflow is a managed orchestration service for Apache Airflow. It is designed to make it easy for you to set up and operate your data pipeline in the cloud, even at large scale. You can use the open source tool Apache Airflow with Python to create your workflows. This means you can programmatically write, schedule, and keep an eye on all the sequences of processes and tasks you need to run. The best part about Amazon Managed Workflow for Apache Airflow is that you don't have to worry about managing the underlying infrastructure. AWS takes care of making sure it is scalable, always available, and secure. Amazon Managed Workflow for Apache Airflow automatically scales its workflow execution capacity up or down to meet your needs. It also works with other AWS security services to give you fast and secure access to your data. So these are the features. You quickly set up Apache Airflow by choosing an Apache Airflow version when you create Amazon Managed Workflow for Apache Airflow. Amazon Managed Workflow sets up an Apache Airflow for you using the same Apache Airflow user interface and open source code that you can download on the internet. You automatically scale Apache Airflow workers by setting the minimum and maximum number of workers that run in your environment. Amazon Managed Workflow for Apache Airflow monitors the workers in your environment and uses its auto-scaling component to add workers to meet demand, up to and until it reaches the maximum number of workers you have defined. You enable role-based authentication and authorization for your Apache Airflow web server by defining the access control policies in AWS Identity and Access Management. The Apache Airflow workers assume these policies for secure access to AWS services. The Apache Airflow workers and schedulers run in Amazon Managed Workflow for Apache Airflow Amazon VPC. Data is also automatically encrypted using AWS Key Management Service, so your environment is secure by default. You access your Apache Airflow web server using a private or public access mode. The public network access mode uses a VPC endpoint for your Apache Airflow web server that is accessible over the internet. The private network access mode uses a VPC endpoint for your Apache Airflow web server that is accessible in your VPC. In both cases, access for your Apache Airflow users is controlled by the access control policy you define in AWS IAM and AWS SSO. Amazon Managed Workflow for Apache Airflow provides new versions of Apache Airflow periodically. Managed Workflow for Apache Airflow team will update and patch the images for these versions. You can view Apache Airflow logs and Apache Airflow metrics in Amazon CloudWatch to identify Apache Airflow task delays or workflow errors without the need for additional third-party tools. Amazon Managed Workflow for Apache Airflow automatically sends environment metrics and, if enabled, Apache Airflow logs to CloudWatch. Amazon Managed Workflow for Apache Airflow supports open source integrations with Amazon Athena, AWS Batch, Amazon CloudWatch, Amazon DynamoDB, AWS DataSync, Amazon EMR, AWS Fargate, Amazon EKS, Amazon Data Firehose, AWS Glue, Lambda, Redshift, Amazon SQS, Amazon SNS, Amazon SageMaker AI, and Amazon S3, as well as hundreds of built-in and community-created operators and sensors. Amazon Managed Workflow for Apache Airflow offers support for using containers to scale the worker fleet on demand and reduce scheduler outages using Amazon ECS on AWS Fargate, Elastic Container Service. Operators that invoke tasks on Amazon ECS containers and Kubernetes operators that create and run pods on a Kubernetes cluster are also supported. Next is the complete architecture of Amazon managed workflow for Apache Airflow. So first we have environment boundary, and this is this part. So all components within the outer box constitute a single Amazon managed workflow for Apache Airflow environment in your AWS account. Then we have second part, which is customer VPC. The customer VPC contains the core Apache Airflow execution components, including Airflow schedulers, that includes base and additional instances, and Airflow workers, and that also have base and additional workers, all running as AWS Fargate containers in private subnets. Next, we have the service VPC components. The service VPC houses the DB database proxy and metadatabase for Apache Airflow, along with Airflow web server. Then database connectivity, which is this part. Each environment has its own Apache Airflow metadata database managed by AWS, and this is accessible to the scheduler and workers Fargate containers through a privately secured VPC endpoints. VPC endpoints is called database VPCE. Then we have web server access modes, which are these two, private and public network. So Apache Airflow web server supports two access modes: public network, which is accessible over the public internet, and private network, which is accessible within your virtual private cloud, with both modes controlled through AWS Identity and Access Management IAM policies. Next, we have external AWS services, which is this part. And 4 AWS services operate separately from Amazon managed workflow for Apache Airflow and must be accessible from the Apache Airflow schedulers and workers in Fargate containers. Amazon CloudWatch for monitoring, Amazon S3 for storage, Amazon SQS for queuing, and AWS Key Management Service KMS. Then we have network security part, which is this part, database VPC and web server VPC. Web server access is secured through a web server VPC endpoint, while database access uses a database VPC endpoint, ensuring private and secure communication between components. And this is the complete architecture. Next is the integration. So first is community operators. The active Apache Airflow community creates operators, which are like plugins that make it easy to connect with various services. This includes AWS services like Amazon S3, Redshift, Amazon EMR, as well as services on other cloud platforms. So full support. So when you use Apache Airflow with Amazon Managed Workflow for Apache Airflow, you get full support for integration with both AWS services and popular third-party tools. This allows you to perform data processing tasks using tools you already know like Apache Hadoop, Presto, Hive, and Spark. API compatibility. Amazon Managed Workflow for Apache Airflow is committed to maintaining compatibility with Apache Airflow API. This means your existing Airflow workflows should work smoothly without any changes. Amazon's commitment. So Amazon plans to provide its own reliable integrations to AWS services and make them available to the community. They also plan to be involved in developing new features for the community. So now I will explain a sample DAG, which is directed acyclic graph. So DAG is basically the workflow. And so this sample DAG or the workflow, so first we have a bucket, and this contains sales data. For example, sales data.csv file. It contains data about sales in CSV format, and this is the task, which is a complete workflow, and it runs at a daily basis. Therefore, task 1, 2, 3, 4, and first task will read the file. It will extract CSV and convert to JSON. Then this data will be passed to the second task, which will clean and validate, and it will produce a clean data, which will be again JSON. this will be fed into the third task, which will aggregate the matrix and will calculate the matrix and store in a sales matrix JSON file. And then finally, this particular the last task will read this and write to S3. So basically, we are doing complete end-to-end processing using this sample DAG. So this is the code. So this is a so one thing, Apache Airflow only works with Python. So first we import some libraries, for example, Airflow decorators like DAG and task. So we use Airflow's task flow API decorators for cleaner task definition syntax. And we import a S3 hook to interact with S3 service. And we use pandas because we will work with CSV, and JSON because we will work with JSON. Then we create a dictionary with some key value pairs like owner, depends on past, retries 2, and retry delay 5 minutes. We configure automatic retry attempts with 5-minute delay between retries if a task fails. Next, the DAG or the workflow starts with this particular syntax. This is a decorator or an annotation. So add DAG. Then there is a DAG ID. There is a default args. So default args will just take all these values. It will add and other key values also. It will have a description. What schedule? So this schedules the DAG to run daily using the Airflow's cron preset. What is the start time of this workflow? And catch up false. So basically there is a feature like catch up true or false. So false, it will disable backfilling to prevent running the DAG for historical dates between start date and current date. If you don't give from this start date, it will run at that many number of time. So it will backfill. So basically whatever it has missed, it will run that many number of times. And we provide some tags. So this is a starting code. We start the workflow. Then this is add DAG, and this we start with the first method. Like this is how the workflow starts. So this DAG is a decorator for this method sales data pipeline. Next, so inside the workflow we have a nested definition task. So this is the first task which I talked about. So first we extract from the S3. So we create a S3 hook and we connect to our S3 account. So this will initialize S3 hook with AWS connection to interact with S3 buckets. Then we initialize file content, which will use the S3 key to read our sales data.csv file, and it's in our bucket. So we specify the S3 path to raw CSV file in the data lake. Next, we use pandas to read the CSV file. So we use the file content and we print some debug statement like length of the data, like how many records are there in the CSV file. Then we return the data. We load, like we convert CSV to JSON, and we serialize data frame to JSON format for passing data between Airflow tasks. So this is the task 1 we extract, or we can load from S3. Next task, second task. So this will accept JSON from previous task and deserialize it for processing. So this is the input parameter raw data, which is the string. So we take this string and we read the JSON file. So so this is part we have done. We read the JSON in a data frame, and first thing we do is to remove rows with missing values in critical order ID and amount column. So we say drop NA. So whichever rows have null values, it will drop. Then we will filter out amount, filter out invalid records where amount is 0 or negative. So we do 3, like order ID, amount, and amount if it is less than 0 or negative. So we remove the bad data. Then on the order date column, we convert it to a date time so that we can do aggregation better. So we convert order date column to proper date time format for aggregation. So after we have done the cleanup and proper like standardization of data, we just print out clean data, and we can calculate number of records for debugging, and then we return this df to JSON again, and this will be sent to the next method. So this is method number 2, right, or task number 2. So this is third task where it will get the clean data from so this is we call aggregate matrix. So this has task annotation. Then this will read using pandas, read JSON. We get a data frame, and then we group sales by date and calculate total revenue and order count per day. So we do a sum and order ID count, and we group all this data. Then this daily sales, which we got these columns, we create a kind of a CSV like date, total revenue and order count. And then we create some metrics, like we build a comprehensive matrix dictionary with overall and daily breakdown statistics. So we have like total revenue, how much is the total revenue, we sum it, total number of orders, how many is the total number of order, and what is the average order value for a date, and the daily breakdown, and all this information we take from this daily sales. And apart from this, and we have some like debug statement like total revenue, total orders, we print it out, and finally we dump all this matrix, because this is a dictionary, and then we finally dump it to a JSON statement and we return. So this will pass this to the next task. So this is our third task. And lastly, we have the fourth task, which we call it load to warehouse, or we can say save to S3, or you can save to Redshift or wherever. But in this case, I'm just saving it to S3. So again, we initialize a S3 hook with our correction ID AWS default, and this is the S3 bucket or the key where we will save. So output key is something like in the bucket processed sales metrics, and whatever date it's processed .json. So every day it will have one separate JSON file. So it will take this matrix string which is passed from the previous task, and it will load string here, string data matrix. So this matrix goes here, key where we want to save this JSON. This is the bucket key and the bucket name. So this is a separate bucket name. So we generate timestamp file name for the process matrix using matrix output using current date. We write the processed matrix to a separate data warehouse bucket. So we take from a different bucket and we write to a different bucket. We have some debug statement. Okay, matrix loaded to, and we print out the actual file name, and we return the output key. Finally, we will define task dependencies by chaining task outputs as inputs to sequence. So how we read is, so first is raw data. So we extract from S3. So this is the first task. There is no input parameter. So raw data. So raw data comes here, right? And whatever this is returns, it will be saved here. It will have a reference here. This goes here, clean and validate, and this will do the processing. And whatever the output comes, this will be referenced by clean data. And clean data comes here, then aggregate matrix, then matrix is referenced here, and the matrix input parameter will be passed here. And finally, load to warehouse, which is the last task, and that will save it on a daily basis in a JSON file in that bucket. And finally, we instantiate the DAG to register with Apache Airflow scheduler. So this is complete end-to-end example of a DAG workflow in Apache Airflow. And that's all. Thanks for watching.